Okay. So in this session, the topics that I will cover are the geospatial data and how does it differ from other kind of data. What makes the geospatial data so special? The next point we'll discuss is a brief on GIS and what are the various components, because data is one of the important components of a GIS system. Because when we talk about information system, then data is one of the components of that system. Next, we'll discuss briefly the typical life cycle or the steps that are involved in a GIS process, followed by the various types of data sources and what kind of consideration to be kept in mind while deciding or choosing the data. So we all know what a data is. Data are the raw facts. The moment we add the word geospatial data, so we are meaning to say that a data that describes not only the location or where certain things are, but also the characteristics of that spatial feature that is occurring at that particular location. For example, if we take a road as an example, which you can see on the infographic on the right hand side, the street network. And if I pick only one segment of the street, let's say this. So starting from point 1 given by the x and y on the right hand side here, going up to the point 2, which is the second point of x and y. And not only the location or the points that denote the starting of the segment and the ending of the segment, but also the characteristics of that road, which is what is the length of the road. So in this case, it is 755 meters. The name of the segment is the State Highway 8, and what is the speed limit is 35 miles per hour. And other characteristics is the direction, whether it is a one-way or a two-way traffic. So primarily geospatial data not only talks about the location, but also the non-spatial attributes or characteristics that qualifies the data. So basically the attributes add impetus and also qualifies the location component that we are capturing and maybe analyzing in a geospatial data, in a GIS-based software. Now talking about GIS, so there are three terms, GIS. So G stands for geographical, second is the information, and S stands for system. So a GIS is a computer system which allows for capturing, storing, querying, analyzing, and displaying the geospatial data. And we can also compare it with an MIS if you want. So the answer that a GIS can give you, which an MIS can't, which is like if I'm looking for a location of those employees with reference to IIRS, which are of a particular designation and which are living within, let's say, 1 kilometer vicinity of IIRS. Then GIS, because of the spatial capability of relating the location of the employees with the location of IRS, will be able to tell you that answer, whereas the MIS can only give you how many employees have a particular destination. And talking about the components of the GIS, as we talked about, it is a computer-based system, so it will have the various components like hardware component, the software component, the data, which is the focus for this lecture, and also the people who will be using that software and the hardware to get the desired results. Now, talking about the hardware, it is not only the machine on which the GIS software is running, but there are also ancillary softwares that works along with the GIS. This could be your mobile tablets, this could be your GPS devices, this could be scanners and printers for scanning of the maps or printing of the final output. The second component is the software, which is a base. So because we are moving from the, let's say, the manual method to a computerized system, so software will provide you the capabilities, which could be the inputting capabilities, the storing, manipulating, displaying capability, map compositions, those kind of things, and also the spatial operations kind of functions that are available from the software. The third important component is the data, because without which the software will not work. Even a powerful software will have so many algorithms, but unless you give them the data, it will not be serving the purpose. And fourth component is the people, which are the actual users of the software who use software, feeds the data, and then finally generates the result. And talking about the define, let's take an example that we are looking for a site suitability, which is a classic example of GIS being used very prominently. let's say we are looking for a new location to set up a new facilities, and then next step is we have to define the criteria. So criteria could be which is a proximity to the harbor, proximity to certain connectivities. It could be main communication routes should be available, and also where the proximity to the clients that you are targeting should also be available. So having defined the problem that I want to set up a new location, and also defining the criteria that what should be my criteria for finding out the suitable sites, then the next important step is the importing or the creation of the data, because as I mentioned previously, without this, that the software will be of limited use, followed by the using of the various GIS-based analysis that is available in a typical GIS software, using that analysis output to generate the map composition, and finally taking the output either in the form of a map composition or other digital mechanism to make a decision. If it suits the purpose, well and good, we go ahead and use it. Otherwise, we can further refine the problem and further define the criteria, followed by creating new kinds of data sets, and then coming up with the refining the analysis and computing the results. So as I mentioned, the GIS process having the capabilities of defining the problem to all the way to the decision making, it is very, very useful and can be easily done in a typical GIS environment. Only thing is we have to, from the user's perspective, you have to define the problem. The problem could be generic, could also be specific to a typical supply chain problem. And then from the user's perspective, they have to provide what kind of a criteria that I have to set. An important thing is what kind of data sets that I have based on which I can perform the various analysis. Talking from his perspective of GIS data, now this is, I hope you will agree with me that this is the most expensive part of the GIS software, because this is where a lot of time is spent, not only the money, but also the effort in collecting the data from various sources, also creating from our own sources. As you are aware, data can be of two types. One is a primary source, or second is from the secondary source. So in case you are looking for own creation of data, then also there's a lot of time and effort being invested. Initially, we used to work on a paper map that was digitized to bring into a GIS environment, followed by creating of the databases. But now, with so much data being available, as you must have studied in the previous sessions, that there's a lot of data being already available in the various kind of geoportals or spatial data infrastructures, where the various organizations start putting the data which the end users can use it. So before deciding for creating of your own data sets, always better to look for whatever data is available in the public domain. But also one thing you have to consider before utilizing those data sets is to aware of the term called a metadata, which we call as a data that describes the data, because metadata will help you find the fitness for use for that data, whether the data is current, who has created it, for what purpose it was created, what kind of accuracy levels that are available, and what kind of date time stamping that it has. So all these things have to be kept in mind before deciding to use some certain data. And also in certain cases, you have to convert from one format to another. And sometimes it is dependent on the software that you are using. For example, in a particular software, sometimes you are limited by the software that we are using, so that software will work on that particular format only. But nowadays, with the open standards being coming in, it's not no longer a problem, and the data could be converted. Let's say if you have a data in certain formats and you want to bring it to another format, so GIS software will provide also various kind of conversion utilities that you can use for converting from one format to the another. Now, having said that, in case you are not able to locate the data that are in the public domain, then you can also create the data of your own that we call as a digitization process that I will cover in the subsequent slides. Now, talking about the various types sources of data. So as we have maybe learned in the previous session, so sources to our data could be a satellite images, your remote sensing data sets that could be from the aerial platform or the UAV platform. Second is your field data, that sometimes we go to the field and also collect the data. The data could be in the form of text file or an Excel file, which can contain the location components, the longitude or the latitude. That can also be bring into the GIS in the form of let's say a point layer. Similarly, sometimes we also have the street addresses, and then we can convert those street addresses to the actual location. The word we use is a geocoding, and we can also do a reverse geocoding, which is given the longitude and latitude, we can also find the address. There are various kind of utilities and the APIs are available that I will talk in the subsequent slides. Sometimes we have the maps in a paper-based formats or done through a land survey mechanism that we can also bring into the GIS by scanning, digitizing, and bringing into GIS by georeferencing them. GPS or the GNSS kind of constellations also provide us a valuable source of data that we can capture. And again, the output of the GPS, either in the form of a GPX file or a shape file, could again be bring it in the GIS environment and also be interlinked with the other formats. Nowadays, with a lot of geoportals coming in, the primary means from the Indian context is the ISRO Bhuvan portal, and which provides not only the services but also the open data that you can also use. One important site for looking for the data is the India Data Portal, which is a main storehouse where all the different organizations from Indian perspective are contributing the data. Nowadays, there are a lot of mobile-based data collection apps that are available with the coming of the smartphone, the penetration of the internet, and then the availability of the internet, and also the reduction in the price of the data has led to the new kinds of data collection mechanism where the mobile-based smartphones, which comes with a camera and the GPS on board, could be used for capturing the data. And then primary mechanism is the crowdsourcing. Just like outsourcing, we outsource the job to the third party. Here we can also use the power of the volunteers. The other term that is used for crowdsourcing is the volunteer geographic information given by Michael Goodchild, which talks about how people on the ground with the smartphone can be used as citizens, as sensors, so that they can also contribute in the data collection. And if none of these things are there, then we have to work to create our own data, that is the manual digitization process, which starts with the scanning, and then bringing to GIS, and we do a digitization on the GIS platform in a digital environment. So talking about the first point, satellite data. So there are various sources of data. The primary, you can go to this Earth Explorer site, through which a single interface you can look for various kinds of data sets, both free as well as the paid option. So you can supply the type of data that you're looking, the type of feature here that you are looking, the date, the from, and the to date that you are looking. You can specify the type of amount of cloud cover that you want to filter out, and then you can arrive at your desired data sets. The second important site from the Indian perspective is the Bhuvan Geo Portal. The website URL is bhuvan.nrsc.gov.in. Apart from the various visualizations, both 2D and 3D, it also provides the Open Data Archive. I will request you to please visit this Open Data Archive section. By the way, Bhuvan provides a single window to experience, explore, and visualize the Indian remote sensing images over the Indian region, and you get a very much high resolution data up to 1 meter for the whole India. So there are various other utilities in here. I'm focusing only on the Open Data Archive. So if you open that Open Data Archive section, you can see the various types of satellites and products that you can download. So you can download the remote sensing data from resource set 1 and resource set 2, the list 3 sensors, and also the A-waves and other Cartoset 1 DEM is also available for the whole India that you can also select and download, and then other physical products are also available. Before downloading, you have to register, and then you have to provide your email ID, and then you can subsequently use for downloading the data. So having talked about the raster data, but what about the vector data? So OpenStreetMap is a volunteer contribution kind of information where the volunteers are contributing the data for the whole world. So not only we can be a contributor, but we can also be the utilization for this data. So one way is you can go to the website, which is openstreetmap.org, and then there's a section here called an export. You can specify your bounding box. So what you can see here is the bounding box. the top left and the bottom right, and there is an option of export. So once you export, the whole data will be exported, the whole geometry along with the attributes. And on the left hand side, you can also see there are other other links are also available. So apart from the main link, you can also go to the GeoFabric site, where you can also download the data. On the main site, you can also go to the GeoFabric site, where you can also download the data in a GIS native format. So you can draw your bounding boxes, and all you can do straight away by using this simple QGIS interface. You don't need to move from one software to the another, and automatically it will show you the bounding box. Then you can specify the location where you want to store the data, and there is also an option of loading the layer into your table format. The moment you click on OK after supplying the shapefile, the location where the file should be saved, the data will automatically be loaded in the form of the polygons which define the area, and then the lines and the points. That is all that you can see on the OSM site. So you can get all the data along with the attributes associated with that. So you can see that you can also get the road names that we are able to get from the OSM data. The other type of data that we also capture by going to the field is maybe in the form of a comma separated values, or in the form of an Excel file, where we go to the field and maybe note down capture the location along with a series of attributes. So that kind of data can also be bring it into a GIS environment. Here I'm taking the example of a points of interest. Let's say, so here I'm capturing the points of interest. So have a fields like comma separated value, the state, the place of the points of interest title, the longitude and latitude. For example, the state name is Andhra Pradesh. Undervalley Caves is the archaeological site, and then the longitude and latitude is given. So this could be your for any kind of other assets that you can take. For in the case of a supply chain management, you want to capture your assets, so you can go with the GPS on the field, or and then you can note down these kind of information in maybe in the notebook, and then later bring it into the GIS and convert into a digital format. But having this kind of information wherein we have the comma separated values along with the longitude and latitude. So this can be converted into a point geometry in a GIS by using the simple utility in the QGIS. Here we go to the layer option, click on add layer, and then there's an option of add delimited text layer. So as the name suggests, comma separated, it could be tab separated, it could be semicolon. So the moment you enter the click on this, sorry, the window will open, and then you can specify the various options. What is the file format? In my case, it is a CSV file, comma separated values, but you can also give some custom delimiter. You can give a tab, semicolon, whatever. And then we can, I'm going back to the previous screen just to tell that here in my case, the first line is the header, because it denotes that I'm storing the state, title, longitude, and latitude as 4 kinds of fields which are separated by comma. So here in the software, that also provides us an option saying how many are the header lines that you want to discard. So here, if you have more than one header line, you can enter that. And we can say that first record has a field name. So the field names will be picked by creating that point geometry. The point file will have the same field name. And then the second record will have the So we are talking about the geometry definition. So you can also specify the point coordinates. You can pick from the, if you have more than fields, you can pick the corresponding longitude and latitude field. The important thing is what kind of projection system this data is. So by default, the GPS coordinates are in the geographic latitude and longitude. So this will be covered in the subsequent lectures, but important thing is we also have to specify what kind of projection system that we are using. And below you can see the sample data that is available. The moment I click on the add button, you can see that the non-spatial information has been by the point locations by this red diamond. So I can find out the attributes and also the location I am able to visualize. So this is a Bhakteshwar temple somewhere in Madhya Pradesh. So this can be used for your asset capturing the, and then you can bring them the data directly into the GIS environment. The other important concept and the utilities that we have in GIS is the concept of geocoding or the reverse geocoding. For example, I hope you have, if you are looking for a certain place, you must have gone to certain geoportal, let's say the Google Map, and then you have, if I just enter the IIRS address, let's say Fort Kalidas Road, it will point me to that particular location. So this is something we call as a geocoding, and similarly we can also do the reverse geocoding. So from the various API perspective, the popular API for geocoding and reverse geocoding is API, and then on the left hand side you can see that not only the geocoding API but the other APIs, to please explore the other also be used APIs, for example for the, let's say the routing, and reverse geocoding is the opposite of that. So we convert the geographic long coordinates to the human readable addresses, and sometimes it becomes very important because in a certain scenarios we will be dealing with either with the addresses or the coordinates, and we want to know where that place is. So that becomes very important. Now again, you can use those APIs for getting the task done. But again, if you want to work on the same one, if you want to work on the same environment, GIS environment, then again there are a lot of plugins available. The popular for geocoding and reverse geocoding is the MMQ GIS. I request you to please install this and explore this option. So once you have installed this plugin, the menu will be added into your menu bar, and then apart from the other services, you have the geocoding services. So you can do a geocoding using a CSV file, using the web services that I talked about. So once you click on that, and then you can input your CSV file wherein you have your comma separated field for address, the city, the state, and the country. So let's say for Kalidas Road, comma, Dehradun, comma, Uttarakhand, comma, India. And then you can choose the web service like Google. But before that, you have to register in the Google API, provide the API key, and then the output can be automatically converted into a shapefile that you can visualize. So conveniently, you are able to do your address to coordinates and also coordinates to address location kind of a functionality could also be done. This is very important concept when it comes to the GIS. The other important site for looking for data is the data.gov.in, wherein various organizations of the various ministries are contributing health related data. I was able to get the data from this. So not only you will be able to capture the data or gather the data from various authentic sources, but also there are a lot of applications that people have built and then put into that for to visualize and maybe come this data.gov.in, that could be quite useful to come up with your own solution to a typical problem. So these, so based on your type of problem that you have, from health and family to all the way to transport, to labor, to urban, from data from various ministries and institutions are also available, along with metadata. How to use it is also very useful, as you talked about. And now the other important concept when it comes to the GIS, since you are talking about the data being captured from other sources, let's say if you have also captured the data from the census data, how we can bring it into a GIS. So GIS provides the capability of joining the spatial data with the non-spatial data. Now, those with a DBMS background will know this is a typical join operation where we join based on the primary key and the foreign key. So what we require is the common attribute. Only the data type has to be the same. The field name does not have to be the same. For example, I'm taking an example of a state wise data, and then I have the census data of the state wise, where I have the information of the number of household, the total population person, total population male and female, and so on. So we can also bring it into GIS by using a join operation by providing the common attribute. So once the data is being joined, so what the data that was in separate from the GIS environment can now be bring into a single seamless GIS system, and then we can also visualize and see and then depict using a choropleth map, let's say, which kind of a state has more population person, more population male, and so on. So not only the bringing of the GIS data, but also linking and joining with the spatial data is also one of the characteristics of the GIS. Now, I was also talking about that for capturing the data, now there's a lot of mobile apps are being also coming in, also with the smartphone coming in with the GPS or the GNSS devices on board, which allows you to capture the location along with the attribute information. So you see a various gamut of tools that are available from both from the proprietary as well as the open source. I'm focusing only on the open source. So you have a tools like QField, which is a variant of QGIS on the field for on the Android kind of devices. And the widely popular use is the Open Data Kit, which is a complete end-to-end solution from designing of the form to data collection app to the visualization platform and the storage platform, wherein you can visualize and download the data. There are other tools that I mentioned on the slide here. GeoPaparazzi is again for Android, and also GVSec that is available for Java-based and also for the Windows-based mobile devices. Now, in the recent, due to COVID, this kind of a mobile apps in widely being used for carrying out the facility-based surveillance, and you can also use it for your for data collection and also for other kinds of tasks. The typical advantage of going with the digital-based of data collection versus paper-based collection is we are saving the time, because because we are eliminating the need for secondary data entry step, because it is like going to the field with a notebook and a pen. And then you note down with the paper and pen, again bring it in. Once you come back to the office, you have to again convert into digital form. By using with the mobile based or a digital mechanism data capture, the speed of transmission is also faster. Then a lot of data can be captured in a fast amount of time. Right from the field, the data could be fetched. This mobile devices or this mobile apps can make certain field as mandatory and non-mandatory, so it ensures that there is no omission error. So all the data is being correctly fed by the person going to the field, and also there's a lot of richer data being captured. So not only the pictures, the geotag photographs, the business logic could also be kept. For example, a certain field is of certain data type, or the value in a certain field should be of a certain range, let's say 0 to 100, and those kind of logic could be built in, which make sure the data that we are capturing is accurate and there is not much chance of data inaccuracies. One of the solution is the Open Data Kit, which is, as I said, is a complete end-to-end solution. So there's various other tools. One is the ODK build, which is for designing your performer. So if before going to the field, you have to decide what all fields that I will capture, so that you can do with a graphical user interface like ODK build. Then there is a ODK validator, which way you can validate the form that you have captured. This ODK aggregate is your server environment, wherein the data that you collect from the mobile device will be stored and visualized. And then ODK Collect is a mobile Android app that is again open source that you can download, and the form could be downloaded from the ODK aggregate, and then user can carry on the data collection process. Once the data has been captured, it could be submitted to the aggregate server where you can see the images, the point, location, and all the attribute information that you can capture. And that data could be either exported in a CSV file or Excel file, or it could also be visualized on a mapping interface, either using a Google Map interface or some other interfaces. So this is where the ODK is popular in the sense that it is completely, you don't need to learn any programming language to use it. It is as simple as going to this build.getodk.org, and then you can design a simple performer. For example, if I want to capture my assets, let's say, and then I have just field option, so I can click on the add and then add whether I want to add a text field, numeric field, location field, media field, and so on. So I've added the name of the observer who will be capturing that field, what kind of assets that I'm capturing, what is the location, I'm also capturing the photograph. And this is a simple user interface where you can make certain fields are mandatory. You can also create a drop-down list, so in case the user don't need to type it, he can just pick it from the list. So if you see, it is a very, very easy to use solution and been quite popularly used sorry, in various kind of environment for data collection. And since it's an end-to-end process, and further thing is completely open source, so people are using it for quite widely. Now, having talked about all these things, now in case you don't have the data from the public available sources, and then you have the data, you have to make your data yourself, then that process is called as a digitization process. So process start by bringing the map into a GIS environment. So let's say you have a paper map, so you'll first scan it, then and then you will convert into a TIFF format, then open that into a GIS, then georeference it. Once the map is georeferenced, assign the coordinates, then it is like tracing on the sheet that we do on our school days, where we take the image on the top, we put the tracing sheets, and then we use the pencil for tracing out the features. So like this, I can, for example, this is the map and I want to capture the place name. Change the various cities, the place. This is a topo map, by the example. By the way, I'm capturing this name, so I can just, as we talked about the shape, storing the geometry, it could be in the form of point, line, or polygon. So it is like, as I said, the tracing. Just click on the point and then tell that this is a. I'm capturing the name of the place, which is Hathi Bartla. There could be other series of attributes that you can design by defining the schema when you create your shape file. So you can define what kind of fields that you want to capture. Similarly, for the line, as you know, line will be a linear feature. So series of points will make a line. So other thing that you have to remember that you're not getting into this is the type of file formats to use for data collect, for the storage of the files. But thing is that with the reference to the shape file, one kind of feature can go in one file. That's why for each feature, you have to create a new shape file. For example, to digitize the railway line, I am creating a new geometry layer, and then I'm using this button for capturing the line, which is like a point click, point click, point click, point click, and point click to make the line. And then finally, I can add the attribute to that. Similarly, to capture the area, and we know area will be a kind of a surface or a polygon. So we start digitizing, as I said, point and click, point and click, point and click, and wherever you want to stop, just double click, and then you can follow by entering the attribute for those features. So if we see, this is a quite simple process wherein just we have to do a tracing over some georeference layers. So not only the paper map, but nowadays with the lot of OGC services being available, for example, the Bhuvan satellite images could also be brought into the GIS environment. And as from in the previous session, we have learned that a lot of information can also be captured from the satellite images. So you can also trace those features out from the satellite images. Similarly, Bhuvan also supports crowdsourcing other web-based data creation mechanism. So there is a tool called online shapefile creation tool that you can use. So you can also digitize. Here I'm showing the example of I'm zoomed to the IIRS campus, and here I'm digitizing the buildings. And then the good thing is not only you are contributing to the Bhuvan database, but you can also save them to your local in a GIS file format, and you can bring it into the GIS environment. So in this session, I have covered about the geospatial data, and we talked about that the geospatial data deals not only with the location but also the characteristics. Then we talked about the how does a GIS differs from an other information system with the capability of storing, capturing, analyzing, visualizing the geospatial data. Then we have seen the components of the GIS, which is about the hardware, software, data, which was the focus where we are the importance for analyzing, and the people who will be using that data are the components of the GIS, followed by the typical GIS process. We start with defining the problem, defining the criteria, and the important emphasis step was to import or create the data, followed by the various analysis algorithms or utilities that are available in GIS, bringing the output and making the decision based on those outputs. And then I have delved into various kind of data sources that could be satellite images, that could be your street addresses. You can do geocoding and reverse geocoding, the telemetred text files or a CSV file that could be brought into the GIS environment, the various types of the geoportals through which you can download the data, not only the raster, the satellite data, but also the OSM for where you can get the vector data, and then how from the GIS environment itself, let's say QGIS, you are able to work on download the data of OSM. So I have discussed the various plugins, OSM downloader for doing that. Other was for importing the delimited text file. So those options are also available. Important thing is you have to remember what is the delimiter that you are using, what is the attribute name for the longitude and latitude, and will automatically convert it into the point. And then we have also seen the other kinds of data sources, the prime important being the nowadays being mobile-based apps being available. I focus only on the open source, but there are proprietary options also available, and also the cloud-based options also available that could also be explored. And finally, we also have learned about the digitization process. So in case the data sets are not available, or you want, if there's old or maybe not current, then you can use this digitization process for creating our own data, not only the geometry, but also the adding the attributes. That could be the point, or could be a line, or could be the polygon. So with this, I will close. So please do send your questions to the email ID that I mentioned, and we'll love to answer that. Thank you.